Kia ora koutou, tai tamariki, nau mai haere mai. This discussion is going to be about a normal distribution, but it's going to be what's called a standard normal. Now let's just revise a wee bit here. The normal distributions change depending on their mean, mu, and standard deviation, sigma. So closer or smaller the standard deviation is, the more consistent the data. So whichever one of these is the flattest, most spread out, that's going to have the biggest standard deviation. As we said before, standard deviation is a measure of spread. The bigger the standard deviation, the more spread out the data is. The smaller the standard deviation, the closer together the data is. Now, the standard normal distribution is going to be the topic of this chat. And the standard normal, or the standard normal distribution, is a normal distribution with a mean of 0 and a standard deviation of 1. So if you had collected data from the field, the mean would probably be something other than 0, and the standard deviation would be something different as well. And this makes it challenging to compare sets of data. So if we take a set of data and standardize it, what happens is now the mean mu is 0. And each standard deviation is 1. So what happens now is by standardizing your normal distribution, it makes probability calculations easier, as we can look up probabilities in a Z table or use the distribution functions on our calculators. We're going to use capital X to indicate a normal distribution which is not been standardized, and we're going to use Z or Z values to indicate that has been standardized. Now, this thing called a Z-score is going to be what you're using to calculate probabilities using a table. A Z table tells us the probability of a measurement lying between 0 and Z standard deviations from the mean. And we're going to write this probability as probability of Z greater than 0. To find the probability associated with a Z score of 0.625, we're going to use a table and follow these steps. First, move down the left-hand column to find our first decimal digit. Well, the first was 0.6. So in the table, you can see there's my Z, and we're going to go down until we find 0.6. Now the next number, second, move across the column to our second decimal digit. It was 0.625, 0.60, 0.61, 0.62. So this is the probability of being between 0 and 0.62 standard deviations, but we want 0.625. So 0.6, 0.62, we write that number down, and then keep going over the 5. There's the third decimal digit. So this column is your first decimal digit. This row gives you your second decimal digit, and this number here, your third. And when I have the 5, I go down and there's 16. So you're going to add 16 onto that 24. 0.2324, 2324 plus 0.0016. And that gives us 0.2340. Okay, so after we added those together, that's how we use a Z table to find the probability of being within a certain Z score from the mean. Lastly, when answering questions, it's always useful to follow these steps. Always sketch a normal curve. You're going to be drawing lots of these. The more you draw, the more you get good at using them, the better you're going to do on your external. I know a lot of you are sitting down trying merit to excellence. This is going to be your key to 4 merit level excellent credits on an external. So you're going to also, after you sketch your curve, you're going to label the mean and the standard deviation. Label them. And then shade the required region. Find your value or the probability, and then state that Z score clearly to calculate the probability. Let's do an example together. Calculate the probability that the Z score is greater than 1.251. Solution. First, we're going to draw a normal curve. Sketch in our mean, our 0. And since we want it to be greater than 1.251, we're shading to the right. That way is greater than that number. All right. And we're going to go to our Z table. We're going to look up 1.251. Again, the first is my 1.2. 1.25 gives me 0.3944. We'll write that number down. 0.1251 is we're going to add a 2 onto that 44, which gives us 46. So there's the probability of being greater than 1.251 standard deviations. Rather, that's the probability of being in that region. We want to find the probability of being greater than that. All right, so this is another type of problem you might see. You will probably see it. So there's the probability of being within or less than 1.25. Since you want to find the amount greater than 1.25, we're going to keep in mind that all the data is split in half. So the probability of being above 0 is 0.5. Well, if the probability of that half is 0.25, I will subtract the probability that I found from 0.5, and now I get the probability of being greater than 1.25, which is what the question asked. Right? So there's your probability of Z being greater than 1.25, 0.1054. Email any questions my way. Thanks for watching. Hope that helped. Mauri mahi, mauri ora.